Hi everyone, so I'm going to have a recap on the whole unit of organic chemistry so that you have a quick summary of the whole unit. So organic compounds contain carbon and hydrogen bonded together, and one example of organic compounds is fossil fuels. And fossil fuels include coal, natural gas, and petroleum as examples. And usually, so petroleum is a mixture of hydrocarbons. So hydrocarbons contain hydrogen and carbon only, and we need to separate the petroleum, and this is done by doing fractional distillation, and we get different fractions from that. So these are the fractions. So where you have the lightest fractions going to the heaviest fractions, and you need to know the uses of these fractions. So these are the uses that you need to know. Next, you have compounds that are hydrocarbons, so which contain carbon and hydrogen only. One example of a hydrocarbon is alkanes. Now the name of all alkanes end with ane, and the general formula is CnH2n plus 2. This is for alkanes. Let's look at the physical properties of alkanes. All alkanes, they are insoluble in water. They are less dense than water. They are all flammable, but as the number of carbon increases, the flammability decreases. So what happens is that as the carbon becomes in higher percentage, so as number of carbons increases, it has higher tendency of going for incomplete combustion. And also the melting point and boiling point increases with increasing carbon atoms. This is because the van der Waals forces increases. So the alkanes become more packed, so there's more interactions between the alkane molecules. These are all the physical properties. Chemical properties will include reactions that are undergone by alkanes, and alkanes have two kinds of reactions: combustion and substitution. And for you can have complete combustion or incomplete combustion, and complete combustion occurs in excess oxygen and it gives out carbon dioxide and water as the only products, while incomplete combustion occurs in limited amount of oxygen and it can give carbon dioxide, water, as well as carbon or carbon monoxide. So carbon is soot, that black substance is soot. And for complete combustion, you have the blue flame, and for incomplete combustion, you have that yellow or orange flame. For substitution reactions require the presence of UV light, and it also requires to have halogens. So, for example, you can have methane reacting with chlorine in the presence of UV light. You are going to get chloromethane plus hydrogen chloride. And you can have multiple substitution where you can have the chloromethane here reacting with more chlorine and give you dichloromethane plus hydrogen chloride. This can keep on going, where you have the dichloromethane reacting with more chlorine, giving trichloromethane plus hydrogen chloride gas, and then the trichloromethane can react with more chlorine to give you tetrachloromethane plus HCl gas. And all of these reactions require the presence of UV light. So UV light and a halogen, and you're going to have substitution reaction. So these are the two chemical reactions undergone by alkanes. The second type of hydrocarbon that we have is alkenes. So alkenes, they end with the names end with "ene", and the general formula is CnH2n. And for alkenes, we also have two kinds of reaction. We have combustion reaction, and we also have addition reaction. And for combustion, again, you're going to have complete and incomplete combustion. So complete and incomplete combustion. However, alkanes have more tendency towards incomplete combustion. So there's more chance that you're going to get carbon monoxide, carbon dioxide and water. So you're going to have a sooty flame here. And the second type of reaction undergone by alkenes is addition reactions. Now there's three kinds of addition reaction. There's addition of bromine, bromination, addition of hydrogen, hydrogenation, and addition of water, which is hydration. Now during an addition reaction, the double bond in the alkene, so alkenes have C double bond C as the functional group, and during an addition reaction the functional group splits, and then you have the bromine that is going to add to it. So for example, if you have ethene, you have bromine that is going to be added to that, and you're going to have here, you still have the ethene part, and then the bromine will add here. So Br and Br. So it splits that double bond. And this occurs at room temperature. So the conditions for this is bromine and room temperature. For addition of hydrogen, so you will have the double bond that is going to split open, and you have hydrogen that comes here. So you have the end product is going to be an alkane, and the conditions are 200 degrees Celsius, nickel catalyst, and hydrogen gas. For the addition of water, it's actually addition of steam rather. So we're going to have water that gets added to the alkene. So here you end up with the alcohol. So ethene gives you ethanol. So H2O splits, and then you have one side OH gets added. On the other side you have hydrogen which is added. Conditions, and these are the conditions. So 300 degrees Celsius, 7 atm pressure, and phosphoric acid catalyst. Now alkanes and alkenes, they can be differentiated. You can use bromine to differentiate between the two. Alkenes is going to decolorize bromine, while alkanes will not decolorize bromine. So you can differentiate between a saturated molecule and an unsaturated molecule. So the unsaturated molecule is going to decolorize aqueous bromine. Now we can also manufacture alkenes. You will need to know about the manufacture of alkenes. And cracking can be made by using aluminum oxide catalyst and high temperature above 600 degrees Celsius. And these are the importance of cracking: to make small useful alkenes, to make plastic, to make hydrogen that is going to be used for the Haber process. So as example, you have heptane, which produces ethene and hydrogen, and you have also pentene, which is produced. So the main essential and important products are ethene and hydrogen. So now we have already looked at hydrocarbons. We're going to look at the organic chemistry of other compounds that are not necessarily hydrocarbons. So alcohol, carboxylic acid, and esters. These are not hydrocarbons because they contain oxygen in the molecule. So the first non-hydrocarbon that we'll look at is alcohols. So alcohols have functional group OH. The names end with "ol", and the general formula is CnH2n plus 1 OH. And you will need to know the manufacture of ethanol. Now there's two ways to manufacture ethanol. Making ethanol from ethene and steam. This is a complex method, and it is a fast reaction, and it produces ethanol of high purity. But we get it from ethene, which is from a non-renewable resource, which is petroleum. and ethanol is produced continuously using this method. However, fermentation of glucose, it's another method that can be used to produce ethanol. And it's a simple method. It's a batch process, which means that every time the fermentation is over, you have to start over again. It's a slow reaction, and once you get the ethanol, you will have to do distillation to get the ethanol from the mixture, and it uses renewable resources. So you just use yeast in there. You need glucose, yeast, absence of oxygen, and a temperature of 37 degrees Celsius. And you get carbon dioxide and ethanol as the product. The carbon dioxide will escape, the ethanol will stay in the mixture of all of this. Now, alcohols also undergo combustion, and during combustion they will produce carbon dioxide and water for complete combustion, and incomplete combustion will give you carbon or carbon monoxide and carbon dioxide and water. The next homologous series is carboxylic acids. Carboxylic acids end with oic acid. They have the COOH functional group and have the general formula CnH2n plus 1 COOH. And carboxylic acids have all the properties of weak acids, so they will react with acids. So they will react with metals to form salt and water. So for example, ethanoic acid plus sodium will give you sodium ethanoate plus water. And they will have pH less than 7, but it's going to be greater than 3, but less than 7. They will turn litmus paper red. So all properties of common weak acids. Now, for the formation of carboxylic acid, there's two processes. There's the lab process or the industrial process. And in this process, you have ethanol, which is heated under reflux with potassium manganate. And this is an oxidation reaction where you have the formation of ethanoic acid. Another way to make ethanoic acid is by natural oxidation, aryl oxidation. And during this process you have ethanol, which is oxidized by oxygen in air, and this is a slow process. It's this process that turns alcoholic drinks like wine or beer sour when they are exposed to air. The last homologous series that we'll see is the esters. So esters are actually formed when you have carboxylic acid that reacts with alcohols. So you have esters. Now, when you're making an ester, so you will have the ester linkage, so COO, which is the functional group, and the name ends with O8. So for example, ethyl ethanoate. And esters are made from the reaction of carboxylic acids and alcohols. And even when you're naming the esters, you always start with the name of the alcohol. So I'll take one example. So propanol plus ethanoic acid. This is going to give you propyl ethanoate. So we start with the name of the alcohol first. Propyl ethanoate plus water. And let's show the reaction. So this is the propanol and this is the ethanoic acid. Ethanoic acid has 2 carbons, 1, 2. And here you're going to have the removal of the water. And you have the ester, which is here propyl ethanoate. So ethanoate, it's from the ethanoic acid, and the propyl here is from the propanol. So here you have an overview of the whole of organic chemistry without anything concerning polymers.